Today we're going to talk about tree diagrams and sample spaces. We're going to learn how to make an organized list to find all the possible outcomes. Tree diagrams are a part of the lesson. They have branches, like mine, so we want to think of a tree when we make a tree diagram. Sample spaces are used in finding probability. The sample space for an experiment is all of the possible outcomes. You can use brackets to show sample spaces. When you need to find many possible outcomes, you can make a tree diagram. A tree diagram is one way to organize information. A customer at Steve's Sub Shop can choose from white, wheat, and rye bread. The customer can also choose from American and Swiss cheese. Create a tree diagram to show all of the possible different combinations of bread and sandwiches at Steve's Sub Shop. So when the customer wants to make a sandwich, they can choose between white bread, wheat bread, and rye bread. So I'm going to make branches representing all three of the options that you have for bread choices. You also can choose from American and Swiss cheese. So if I choose white bread, I might choose American cheese, or Swiss cheese. There would also be the option of having wheat bread with American cheese. I'm sorry, wheat bread with American cheese, or Swiss cheese. Sorry about that. If we chose rye bread, we could also choose American cheese or Swiss cheese. So when you make a tree diagram, you create branches that show the different choices that you have. And then from each choice, you can branch off into the next option that you have. So looking at our tree diagram, we can make a list of the options of the types of different combinations of sandwiches that we could have. We could have white bread with American cheese. We follow our branches, white, then American. We could have white bread and Swiss cheese. We could have wheat bread and American cheese. We could have wheat bread and Swiss cheese. We could have rye bread with American cheese. And we could have rye bread with Swiss cheese. So we've created our tree diagram here, and from our tree diagram we have created a list of our possible outcomes. So how many different outcomes do you have? You can look at your tree diagram and count your last set of branches. 1, 2, 3, 4, 5, 6. So we know that we have 6 different outcomes. And we're going to use the word possible outcomes because that's what you're going to see. 6 possible outcomes is what you're going to see often. So we want to use that terminology. We can also use what's called the fundamental counting principle. Fundamental counting principle. And the fundamental counting principle says that you can multiply the number of outcomes for each choice. Multiply the number of outcomes for each choice. So the fundamental counting principle, you can multiply the number of outcomes for each choice. So what that's going to look like is you can look at your situation. In this situation, we have a bread choice. And so we can have white, wheat, or rye. So that's 3 choices of bread. And we have a cheese choice, which is American or Swiss. So we can have 2 choices for the cheese. So we have a bread choice and we have a cheese choice. So you're going to want to make a space. You have 3 bread choices, you put a 3, and you have 2 two cheese choices, so you put a 2, and you want to multiply those two together. So 3 times 2 equals 6. That means you will have 6 possible outcomes of combinations with the 3 bread choices and 2 cheese choices. So the fundamental counting principle is a way to check and make sure that you did your tree diagram correctly. Number 2, Bob's Lunch Cafe offers 3 kinds of sandwich fillings and 3 kinds of bread. Sandwich fillings: chicken, tuna, ham. Bread: white, wheat, or sourdough. The list below shows some of the possible outcomes of one sandwich filling and one kind of bread. Is the list complete? Well, in order for us to know if the list is complete, we're going to need to make a tree diagram. So we're going to have the choice of choosing chicken, tuna, or ham. And once we've made our meat choices, then we have the choice of white bread, wheat bread, or sourdough bread. So I'm going to need to make a second set of branches, and there's 3 bread choices, so I can have white, wheat, or sourdough. And I will have those 3 bread choices for each type of meat that I choose. So that I need to create a branch off of ham that shows I could have white bread, wheat bread, and sourdough bread. So I can count my branches to see what my outcomes would be. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know I should have 9 possible outcomes. And I look at my list and I have 1, 2, 3, 4, 5, 6. So I know the list is not complete. No. If the list is not complete, then we want to finish it. So we see here we're going to have chicken and white. Chicken and white is there. Chicken and wheat is there. We don't have chicken and sourdough, so I'm going to need to add chicken and sourdough. All right, let's check the next set of branches. We have tuna and white. Tuna and white is right here. We have tuna and wheat. Tuna and wheat is right here. Tuna and sourdough. So we need to add tuna and sourdough to our list. We have ham and white right here. Ham and wheat right here. Ham and sourdough. So we need to add ham and sourdough. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 items on our list. How many possible sandwiches can you get at Bob's Cafe? For sandwich fillings, we have 3 choices. For bread, we have 3 choices, so we're going to multiply those. 3 times 3 is 9, so we should have 9 possible outcomes. And we counted the list, we have 9. So the answer is 9. So you can make your tree diagram, create your list, use your fundamental counting principle to check to make sure that you have the correct amount. You want to make sure though when you're checking the amount, just because you're counting them and there's 9 would not necessarily mean that that's the correct answer. You do want to make sure that you don't have any repeats and that all of them are included, because as you see here, some were left off, and sometimes when you look at a list you might see that like maybe chicken and white is mentioned more than once. So if you're just counting and not reading them, then you might accidentally think that it is correct when it is not. So you do have to compare your tree diagram to your list by reading them and then also using your fundamental counting principle to count your totals. At the local custom car shop, they are offering a discount if you purchase a customizing package featuring their most popular features and choices. You have 2 rim options, 2 window tints, and 3 paint details to choose from. You must choose one of each to receive the discount. Create a sample space to figure out how many different options you have. All right, so what I'm going to do here is I'm going to make a list. And it's going to take me a while if I'm writing everything out, so I'm going to assign letters to this. So for black rims, I'm going to write B. For dark tint, I'm going to write D. And then for racing stripes, I'm going to write R. And when we have our chrome rims, we're going to use C. Light tint will be L. And for flame, we're going to put F. Now we also have a paint detail option of a lightning bolt. We've already used L and B, so we're just going to make up a letter. So we'll use G for the lightning bolt. So I'm going to make my list. So I have an option of black rims, and then I could have dark tint and racing stripes. I could also have black rims, dark tint with a flame, and black rims, dark tint with a lightning bolt. I also have the option of the light window tint, so I can have black rims, light tint, racing stripe, black rims, light tint, flame, black rims, light tint, and lightning bolt. Now I want to switch to the chrome rims, so I can have chrome rims, dark tint, racing stripe, chrome rims, dark tint, flame, chrome rims, dark tint, lightning bolt. And I can also have chrome rims, light tint, racing stripe, chrome rims, light tint, flame, chrome rim, light tint, and lightning bolt. So you can create your list by coming up with an organized way to do it. Notice that I kept my black rims the same, and then I kept my dark tint the same, and I was only changing one thing at a time. Then I needed to change my dark tint to light tint, so I changed that and then only changed my painting details one at a time. So you need to do it in an organized way so you don't accidentally leave any off or you don't accidentally repeat. And of course you can always use a tree diagram to organize that as well. So let's check with our fundamental counting principles. So we have a rim option, we have a tint option, and then we have a paint option. So for my rims I have two choices. It can be black or chrome. For my tint I have two choices. It can be dark or light. And for my paint I have three choices. I can have a racing stripe, a flame, or a lightning bolt. So then I multiply them. 2 times 2 is 4 times 3 is 12. So I have 12 possible outcomes. And then you can count your list and make sure that it's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 possible outcomes and I do not have any repeats so that I know that I am correct. Number 4, Wayne is picking an outfit to wear to school. His choices are shown in the table below. Which of the following diagrams shows all the possible outcomes if Wayne picks one shirt and one pair of pants to wear? So I have the option of a white shirt, a red shirt, and a blue shirt. And I can either wear, Wayne can either wear jeans or khakis with each shirt option. If he chooses a red shirt, he could wear jeans or khakis. If he chooses a blue shirt, he could wear jeans or khakis. So we want to look to see, we have a shirt color and we have a pants option, and we have 3 choices of color for the shirt, and the pants could either be jeans or khakis. That's 2 choices. 3 times 2 is 6, so we should have 6 possible outcomes. We count our tree: 1, 2, 3, 4, 5, 6. So we have 6 possible outcomes. So you want to look at the multiple choice question and figure out which tree matches the tree that we created, and it should be answer A.